Hello everyone, welcome back to Belmont's Math and Science Learning Center lecture series on Math 1010 Quantitative Literacy. My name is Braden Stevens, and today's topic of conversation is the linear function. Now I say function, and I'm sure a lot of you are just cringing right now, but believe me, it won't be too bad. So when I say the word function, you might have a lot of things running through your head, but the basic gist behind a function is it's a mathematical relationship between two different variables. And obviously there's going to be varying levels of complexity in those functions, but some of the most simple and the most useful functions are those that are linear, aka the graph forms a line. And we're going to see how to deal with that kind of today and what those functions look like and how to interpret them. So as you can see, I've got a couple different graphs here. We're going to focus on this one right here first. So let's suppose that we have a pizza shop that just opened. And so I've got my graph here where the x-axis tells us the number of weeks since we opened our business. So 0 weeks would be opening week, 10 weeks would be 10 weeks later, so on and so forth. And our y variable, our y-axis in this case, is denoting the number of orders. And so I've picked out two specific points on this line, 0, 30. Remember, that's always x, y, so it means on opening week we had 30 orders. And our second point being 870. So on week 8, or the 8th week after opening, we made 70 orders. What we want to accomplish here is coming up with some sort of equation that would be able to tell us what happens at week 10 or week 4, all those kinds of things. Be able to say, at this week, what's our order value? Or, if we know the number of orders we want, about how many weeks would it take to get to that amount? So, I'm sure you've learned before, there are lots of different forms a linear equation could take, but the most useful one and the most general one that we're going to look at is what's called slope-intercept form. And that's the one that we look at the most because it is the easiest form of the equation that we can look at and see, I know what this number means, and I know what this number means, and it's the easiest to kind of interpret in that way. And so you might recognize it as y equals mx plus b, where m is your slope, and b is your y-intercept. Okay, so that's all a bunch of fancy words. What does it really mean? Let's start with the y-intercept. Remember, something intercepts something else, it means it collides. So the y-intercept is the point where our line hits the y-axis. So it is the y value when x equals 0, or in other words, where it hits the y-axis. Where it's y-axis. Slope, in this circumstance, is basically how high does it go if we go over x. So essentially, how much does it increase or decrease in the y as we move further and further right or left. Another way that you can kind of look at this, and another way that it's often described, is the idea of rise over run. How much does it go up and down divided by how much does it go left and right. And so a common equation that you'll use in this case is you're going to look at the absolute change in y. So like y2 minus y1, and you divide that by x2 minus x1, the absolute difference in x. So change in y over change in x. Now that we've got that, let's try to construct the equation for our thing here. So let's start with the slope. We've got 2 points here. So if we want to denote this as point number 1, 0 is going to be x1, 30 is going to be y1, and then if this is 0.2, we've got x2 and y2. So in this case, m is y2 minus y1, 70 minus 30, over x2 minus x1, so 8 minus 0, and you get 40 over 8, which is 5. So 5 is your slope. So if we are to interpret the slope here, it means if we are to go right 1, we're going to increase x by 1, y is going to increase by 5. Each one we go over 1, we're going to go up 5. If we were to go left 1, we should go down 5. So that is our slope. The y-intercept here is really easy because it's given to us. Remember, it's the point where it hits the y-axis, or the y value when it hits the y-axis. In this case, it's 30. So our equation here is y equals 5x plus 30. And that would be our equation for this graph, or for this scenario. Where opening week, we have 30 orders, and 8 weeks later, we have 70 orders. Let's do another example. So let's say we're over here. Let's say in week 4, we have 40 orders, and in week 10, we have 88. Do the same kind of process. Again, we'll start with the slope. So m is y2 minus y1 over x2 minus x1. So again, if it helps, go ahead and just label this. It is no shame in like labeling what variable goes in which, just so that you don't mix it up. Another thing of note is you could pick this one to be 0.1 and say that's x1, y1, x2, y2. You'll get the same answer either way. So in this case, y2 is 88, y1 is 40, and then x2 is 10, and x1 is 4. So we have 48 over 6, which is in fact 8. That is our slope. So again, going at it from that interpreting thing, if we let x go up by 1, y goes up by 8. If we go down by, or if x goes down by 1, y goes down by 8. That kind of thing. Now let's do the y-intercept. Now here is the key difference between these two examples. We are not given this point. We are not given our y-intercept. So how do we find it? Well, the thing we can do is remember our equation takes the form of y equals mx plus b. And that equation is going to work for every point on the line, including, let's say, 4 and 40. That's an x and a y. So what we can do is we can plug in 40 for y. We know that m is 8, because we just found that. X in this case is 4, plus b is what we're going to be looking for. So in this case, 8 times 4 is going to give us 32. And if we subtract 32 from both sides, we're going to get that b is 8 as well. So that means our overall equation in this case is y is 8x plus 8. If we're to interpret our y-intercept, remember that means during opening week, we only got 8 orders. And then for each later week, we increase that by 8. So that is how to construct a linear equation. Now let's see how we can implement that. So using our first example, y equals 5x plus 30. Always remember what your variables stand for. In this case, our x is the number of weeks after opening, and y is the number of orders. So let's say we wanted to know how many orders during, or 10 weeks after opening. 10 weeks after opening. In this case, 10 is going to be our x value. And so we can say y is 5 times 10 plus 30. 5 times 10 is 50 plus 30 gives us 80. Let's do the reverse now. Let's say how many weeks after opening until we reach 100 orders. In that case, we know what the number of orders are. So that is our y value in this case. We have 100 is equal to 5. We don't know what x is, plus 30. Okay, we solve for x, which means we need to get x by itself. So we're going to move this 30 over first. So subtract 30 from both sides. We get 70 is 5x. And then we want x by itself, so we undo the multiplication with division and say that x is instead 14. So that means in 14 weeks after opening, we will reach 100 orders per in that week. So a thing to note that especially when you're dealing with real data, things are not always going to work out so nicely. Things aren't going to be completely linear. What this allows us to do, essentially, is give us an approximation. But one thing of note is if we get too far away, let's say we wanted to estimate in week 200 after opening, our estimate with our equation is not going to be as precise because we're so far away from what our original points are. So don't put too much stock in it, but also it's a good way of estimating in this general area. And there we go. That is linear functions. So see you next time for some more quantitative literacy.